M Zain Ul Abideen. Logic. Mastering problem-solving skills for coding success. 1. Introduction, Why logic matters in programming. Rocket, you don't need to be a genius, just think clearly. Let me take you back to when I first started programming. Like most beginners, I was excited. I had installed my first code editor, watched a few tutorials, and typed out my first hello, world, program. It felt like magic. But then something strange happened. As soon as I tried to create something real, even a simple login system, I got stuck. I didn't know where to start. I wasn't sure what steps to follow. I couldn't figure out what should happen first, and what should come next. Even though I knew the syntax of a programming language, I couldn't solve the problem. Direct hit the real problem: syntax is not equal to solution. Many beginners think that learning programming is about memorizing code loops, conditions, variables, etc. And yes, those things matter. But let me give you a hard truth. You can know every keyword in a language and still fail to build even a basic project if you don't know how to think logically. Logic is how you break problems into steps. Logic is how you decide what to do first and what matters. Logic is how you stop being a copier and start being a creator. Brain, let's define logic in simple words. In programming, logic means understanding a problem, breaking it down into smaller parts, solving each part in order, making decisions based on rules or conditions. It's the thinking process behind coding. For example, imagine you want to build a calculator app. Here's what logical thinking might look like. What will the user do? Rightward arrow, enter two numbers and select an operation, add, subtract, etc. What should the app do? Rightward arrow, perform that operation and show the result. What if the user enters invalid input? Rightward arrow, show an error message. Now you have a roadmap. Only after that will you touch code. Baby, a beginner example. Let's walk through a simple task. Problem: check if a number is even or odd. A beginner might immediately write JS let number equals 5, if number %2 equals 0, console.log, even, else console.log, odd. But someone who understands logic would first write this in plain English. Get a number from the user. Divide it by 2. If the remainder is 0, rightward arrow, it's even. Otherwise, rightward arrow, it's odd. They know the reason behind the code. That's logic. Man, teacher, real world story, my friend who couldn't code. I once had a friend named Saad. He spent hours every week trying to learn JavaScript. He copied code from Stack Overflow but didn't understand how it worked. Then one day, I told him, forget code. Pretend you're explaining the problem to a child. He tried that. Instead of rushing into if-else statements, he explained what a login system should do. Collect user data. Compare with stored data. Show appropriate feedback. That changed everything. He built his first working login system without copying anyone else's code, all because he thought logically first. Graduation cap: what makes a good programmer? Not the one who knows 10 languages. Not the one who builds the fanciest portfolio. Not even the one who writes 10,000 lines of code a day. A good programmer is someone who can break down a complex problem into simple steps and solve them, one by one. That's the power of logic. Speech balloon: common mistakes beginners make. Here are some traps beginners fall into. Jumping to code without understanding the problem. Copy-pasting solutions without reading them. Changing random parts of the code hoping it works. Thinking more code equals better logic, it doesn't. Instead, what you should do is understand the problem. Plan your approach. Test your logic on paper first. Only then write code. Hammer and wrench logic in everyday life. Programming isn't the only place where logic matters. Examples: If you're cooking and the recipe says boil water before adding pasta, that's logic. If you're packing for a trip and think I'll put heavier items at the bottom of the suitcase, logic again. If you set your alarm earlier because you know traffic is worse on Mondays, logical decision making. We all use logic. Programming just makes you more aware of it. Test tube simple exercise, try this now. Problem, you're given a list of numbers. You need to find the largest one. Before you write code, do this. Assume you have this list: 4, 19, 7, 22, 11. How would you, a human, find the biggest number? You'd probably look at the first number, rightward arrow, store it as max. Go to the next number, rightward arrow, if it's bigger, replace max. Repeat until the end of the list. Now try writing this in pseudocode. That's how real programmers start. Key summary: why logic is step 1. Logic helps you understand problems before solving them. Logic keeps you from becoming a copy-paste coder. Logic builds confidence and independence. Logic applies to every programming language and even outside code. If you want to become a true developer, not just a code typist, master logic first. Because once you understand how to think, you'll always find a way to solve. 2. Understanding the problem, breaking down what you're solving. Brain, why this step matters. One of the biggest mistakes beginners make is jumping into code before they truly understand what needs to be solved. It's like trying to build a house without a blueprint. You might start nailing things together, but eventually, it collapses because you never understood the structure. This chapter is all about slowing down and learning how to analyze a problem before trying to solve it. Magnifying glass tilted left, the power of clarifying the problem. Let's say someone gives you this challenge. Write a program that prints the total price of items in a shopping cart, including tax. Sounds simple, right? But before you code, you must ask questions like: what format are the items in? Is the tax rate fixed or variable? What should the output look like? Are we rounding off prices? Many programmers ignore this and start coding. Then they get stuck. Not because they don't know how to code, but because they never clarified the problem. Puzzle piece, breaking it down. Let's break the shopping cart problem into small logical parts. Small orange diamond. Step 1, what is the input? A list of items. Maybe each item has a price and quantity. Format, an array of objects. A string? Something else? Small orange diamond. Step 2, what processing is needed? Multiply item price by quantity. Add them together. Apply a tax percentage. Small orange diamond. Step 3, what is the expected output? A total amount with tax included. Maybe formatted as total, $45.67. When you break it down like this, you suddenly see the problem clearly. Now, you're ready to write code because you understand what needs to happen. White heavy checkmark. Real world example, check if a word is a palindrome. Problem. Write a function that checks whether a given word is a palindrome, reads the same forward and backward. Step-by-step logic. Understand the problem clearly. A palindrome is something like madam, level, or race car. Ask clarifying questions. Is it case sensitive? Madam vs madam. Do we ignore spaces or punctuation? Plan the logic. Take the word. Reverse it. Compare with the original. Now, the code becomes simple. But without understanding, you might overcomplicate it or miss edge cases. Hammer and wrench. Common beginner mistakes. Mistake, why it happens. Fix. Jumping to code immediately. Eagerness, fear of wasting time. Take 2 to 3 minutes to write down the problem logic. Not considering edge cases. Lack of experience. Ask, what's the weirdest input someone could give? Misunderstanding what's required. Poor communication. Always rephrase the problem in your own words. Light bulb mini exercise, do it before coding. Problem. Write a program to convert Celsius to Fahrenheit. Before coding, answer. What is the input? What is the formula? What is the output format? Should you allow negative temperatures? Writing this out on paper first can save you hours of debugging later. Brain Pro Tip. If you can't explain the problem to a 10-year-old, you don't fully understand it yet. Writing hand key takeaways. Always rephrase the problem in your own words. Ask clarifying questions even if you're the only one giving the task. Break the problem into input rightward arrow processing rightward arrow output. Write the logic in plain English or pseudocode before touching your keyboard. 3. Thinking before you code the mental dry run brain. Direct hit. What is a mental dry run? A mental dry run is when you take a sample input and walk through your logic step by step in your head, or on paper, to see if it works. Think of it like a rehearsal for your code. You act out what the program should do, as if you were the computer. Lightbulb real-life analogy, acting like a calculator. Let's say you're building a simple calculator that adds two numbers. Before you write any code, do this. Pick a sample input, A equals 5, B equals 3. Mentally perform the logic. Take A. Take B. Add them. Output the result. Expected output, 8. If you were to mentally go through this and realize, wait, what if the input is a string, not a number, you just caught a potential bug before coding anything. Puzzle piece. Why this is powerful. Here's what a dry run helps you catch. Logical mistakes. Edge cases you didn't consider. Steps that are unclear or missing. Confusing or broken loops. Instead of writing and fixing code 10 times, you spend 2 minutes rehearsing the logic and then write it once, clean and confident. Hammer and wrench. Real example, find the maximum number in a list. Magnifying glass tilted left. The problem. Write a program that takes a list of numbers and returns the largest one. Brain dry run with example. Input, 4, 2, 9, 5, 7. Mentally simulate. Start with the first number, max equals 4. Compare 2 rightward arrow not bigger rightward arrow skip. Compare 9 rightward arrow yes rightward arrow max equals 9. Compare 5 rightward arrow no change. Compare 7 rightward arrow no change. Final answer, 9. Dry run complete rightward arrow logic works white heavy check mark. Now, you know exactly how your program should behave and writing the code becomes almost trivial. Test tube. What to do in a mental dry run. Use this checklist. White heavy check mark. Step speech balloon. What to ask. Choose sample input. What's a normal case? Simulate each step. What will happen here? Watch for confusion. Am I sure what happens at this point? Consider edge cases. What if the list is empty? Or negative? Confirm expected output. Did I get the correct result? Brain Pro technique, use a table. Especially for loops, using a simple table can help. Let's simulate a loop that sums up numbers in a list. List, 1, 3, 5. Step current value running total. 111. 134. 159. Final output equals 9. This visual feedback gives you total control and confidence. Police car light. What happens when you skip this step? You write code that looks fine but doesn't work. You get stuck for hours debugging. You lose confidence and think you're bad at coding. You're not. You just skip the mental check. Writing hand mini challenge, try it yourself. Problem. Write a program to check if a number is even or odd. Dry run it with these numbers. 7 rightward arrow should output odd. 12 rightward arrow should output even. 0 rightward arrow still even. -3 rightward arrow odd. If your mental logic handles these cases, you're ready to code. Brain final thought. The difference between a beginner and a pro. Pros don't just write code, they think through the logic first. Sparkle's key takeaways. A mental dry run is walking through your code in your head using real inputs. It helps catch logic bugs before you even start typing. Always dry run tricky loops, conditionals, and input handling. Use tables or write out steps on paper if needed. 4. Ask questions before you code. Think like a detective. Most beginner programmers rush into writing code. They see a problem and instantly open their code editor. But here's the hard truth. If you don't fully understand the problem, you'll write the wrong solution. That's why smart programmers don't start by coding. They start by asking questions. Man detective. The programmer's mindset equals detective's mindset. Think of yourself as a detective. You don't solve a case by guessing, you investigate. Before writing a single line of code, ask: what exactly is the problem? What is the expected input? What should the output look like? Are there any edge cases, unusual situations? What happens if the input is invalid? Should the solution be fast, memory efficient, user-friendly? Brain example: build a login system. Let's pretend the problem says: create a login system using PHP. Most beginners might just start writing code for username and password fields. But a good developer would stop and ask questions to clarify. Where will the user data come from? A file, database, or in memory? Do passwords need to be hashed for security? Should there be account lockouts after failed attempts? Do we need a forgot password system? What happens if the user leaves a field empty? By asking questions, you get clarity, and that gives you control. Crossmark what happens if you don't ask. Let's say you build a calculator without asking. What if someone tries to divide by 0? What if the user enters letters instead of numbers? What if the result is too long? If you don't ask these things early, your app may crash or behave badly, and you'll waste time fixing problems that could have been avoided. White heavy check mark. Ask before you act, always. Even in interviews, professionals never jump into coding immediately. They talk through the problem, clarify expectations, and think through possible cases. This saves time, improves your logic, and avoids bugs. Test tube practice example. Imagine you're asked: write a program that checks if a number is a palindrome. Don't code yet. Ask: what is a palindrome? A number that reads the same forward and backward. Should it work for negative numbers? Is -121 a palindrome? Should it work for decimal numbers? Will the number be an integer or a string? What if the input is not a number? Pushpin key takeaways. Great developers ask questions before writing code. Treat every problem like a puzzle or crime scene. Look at it from all angles. Don't assume anything. Clarify, confirm, and plan. The better your questions, the better your solution. 5. Think in inputs and outputs like a machine. Every computer program is just a function. It takes input, processes it with logic, and returns output. This is the heart of all programming. Whether you're writing a login system, a game, or an AI, everything works like this. CSS input right arrow logic right arrow output. So to solve any problem, you need to think like a machine. Focus on what goes in, what should come out, and how to transform one into the other. Brain simple example: Celsius to Fahrenheit. Problem: convert temperature from Celsius to Fahrenheit. Input: a number, example 25. Output: Fahrenheit, example 77. Formula: F equals C times 9/5 plus 32. This is clear. Now imagine the same idea for more complex problems. You just define what comes in, what should go out, and build the logic in between. Package every problem is a black box. Think of a function like a sealed box. You give it something, input, and it returns something else, output. Your job is to design the box to figure out what logic needs to happen inside. Example, email validator. Input, hello@example.com. Output, true, if valid, or false, if invalid. Logic inside. Must contain at. Must contain .com, .net, etc. No spaces. At least one character before at. Break down the problem into I/O steps. Let's take a bigger example. Create a program that accepts a list of numbers and returns only the even ones. Puzzle piece step-by-step logic. Input, 1, 2, 3, 4, 5, 6. Output, 2, 4, 6. Logic, loop through list rightward arrow if number %2 equals 0 rightward arrow included. Now you can clearly write your logic because your I/O is defined. Test tube practice problem. Problem, write a function that reverses a string. Ask yourself. What's the input? A string, hello. What's the output? A string reversed, let. Once that's clear, you can easily code it. JS copy edit function reverse string, str, return str split, .reverse, .join. Clarity equals simplicity. Stop sign what beginners do wrong. Many beginners write code without thinking about input/output. They write functions without understanding what they're trying to produce. This leads to confusion, bugs, and wasted time. Instead, always ask. Magnifying glass tilted left, what is the input? What is the expected output? Write those down before writing code. Toolbox pro tip, use examples to define I/O. Make a table like this. Input output. Madam. True. Hello. False. Race car. True. This is a great trick for visualizing test cases and building correct logic. Light bulb key takeaways. Always define input and output clearly like a machine would. Write example inputs and expected outputs before you write logic. Your job is to create the steps that convert one into the other. When stuck, go back and check if you understand the I/O well. 6. Break big problems into tiny pieces, the divide and conquer mindset. How do you eat an elephant? One bite at a time. The same goes for solving complex programming problems. You don't solve a huge problem all at once, you divide it into smaller problems and solve those first. Brain why divide? Big problems are overwhelming. But small steps feel achievable. Imagine building a social media app. That sounds scary. But if you break it down. User login system. Upload photo. Like button. Comment system. Feed sorting. Now each piece is a manageable problem. You can focus on one step at a time. Puzzle piece example, build a calculator. Problem, create a calculator that supports plus, dash, asterisk, slash. Break it down. Get user input. Parse the input. Identify the operator. Perform the operation. Display the result. Each of those is a mini problem you can solve individually. Kitchen knife divide and solve. Let's say we need to build a to-do list app. Big problem, right? Let's break it. Feature subproblems. Add a task. Form input, save to storage, render on screen. Delete a task. Detect button click, remove from storage. Mark as completed. Toggle complete flag, update UI. Save to local storage. Convert data to JSON, store in browser. You don't need to think about the whole app at once. Just solve one box at a time. Hammer and wrench real-life coding strategy. When solving a coding problem, write the problem in plain language. Break it into 3 to 5 small tasks. Solve and test each one. Combine everything. Man scientist case study, FizzBuzz. Problem, print numbers 1 to 100. For multiples of 3, print fizz. For multiples of 5, print buzz. For both, print FizzBuzz. Divide. Loop from 1 to 100. Check if number is divisible by 3 and 5. If 3 only rightward arrow, print fizz. If 5 only rightward arrow, print buzz. If both rightward arrow, print FizzBuzz. Else rightward arrow, print the number. Now it's easy to code. Cross-mark the wrong way. Many beginners stare at the whole problem and try to write everything at once. This causes confusion, tangled logic, more bugs, frustration. Avoid this. Always break things down. White heavy check mark the right way, think like a chef. Imagine you're cooking a meal. You don't start by throwing everything into a pot. You chop vegetables, carrot. You marinate the meat, cut up meat. You heat the pan fire. You follow steps. Programming is the same. Lightbulb pro tips. Write to DOS in code like js//todo, get user input //todo, validate email //todo, save to DB. Use functions to isolate pieces, JS function validate email, function save to database. Test one piece at a time. Use comments to describe subtasks. Speech balloon quick recap. Big problems are just small problems glued together. Always break a problem into pieces before writing code. Solve each piece in isolation. Use functions and comments to stay organized. This is how professionals code step by step. 7. Pseudocode first, code later. If you can't write it in plain English, you can't write it in code. Every great programmer ever. Before writing any line of code, I write pseudocode. It's my secret weapon. It helps me think logically and avoid writing broken code. Receipt: what is pseudocode? Pseudocode is fake code, a mix of plain English and programming logic. It's not real code. It doesn't run. But it shows what the program will do. Brain: why pseudocode? Because it forces you to think first. Helps avoid bugs. Breaks down logic before dealing with syntax. Makes it easy to share your thinking. Works in every language. Writing hand: how to write pseudocode. Let's say the problem is puzzle piece, check if a number is even or odd. Here's pseudocode. Mathematica start: ask user for a number. If number %2 == 0, print even, else print odd, end. Now you understand the logic. Then you can easily write code. Python number equals int, input, enter a number. If number %2 == 0, print even, else print odd. See how easy that was? Wrench: real world example, login system. Puzzle piece problem, build a login system. Pseudocode. PGSQL start: ask user for username and password, check if username exists in database. If not, show error. If username exists, check if password matches. If yes, login success, else show wrong password, end. Code becomes simple after that. Logic is already done. Magnifying glass tilted left: why beginners skip pseudocode, and why that's a mistake. Many beginners jump straight into coding. They don't plan. They get confused. They copy/paste from Stack Overflow. And they don't know why their code breaks. Pseudocode helps plan first, then build. Construction: pseudocode in bigger projects. When working on large systems, write pseudocode for each function. Use bullet points or numbered steps. Share with teammates, even non-programmers. Use it to guide your coding like a map. Hammer and wrench: pseudocode for to-do app. Puzzle piece problem, add new task to a list. PGSQL start: user types a task in input box, user clicks add button. If input is not empty, add task to task list array. Update UI with new task, else show please enter a task, end. Now you just turn each step into real code. Tip: pseudocode helps in interviews. In coding interviews, you're expected to talk before you code. If you can write clear pseudocode, interviewers can follow your thought process. You buy time to think. You reduce syntax errors. Speech balloon: real devs use pseudocode. Professional devs don't just type and hope. They plan. They design their logic first. They outline their steps using pseudocode, flowcharts, or whiteboards, then code. White heavy checkmark recap. Pseudocode is a plan for your code written in plain language. Helps you focus on logic before syntax. Saves time, reduces bugs, and boosts confidence. Used by pros, beginners, and during interviews. 8. Write dummy code that doesn't do anything, at first. Start with nothing. Build everything. Most beginners believe this myth. Backhand index pointing right: I must write code that works right now. Wrong. When I start, I write code that doesn't do anything. I call this dummy code or a skeleton. It's like setting up the foundation before building a house. Building construction. What is dummy code? Dummy code is placeholder code. It has no logic, no data, no real behavior, just structure. It helps you break the fear of the blank screen. Define the architecture of your app. Focus on layout and flow first. Fill in the real logic later. Lightbulb real-world analogy. Imagine you're writing a book. You don't start with the full story. You first write Chapter 1, Introduction. Chapter 2, Conflict begins. Chapter 3, The twist. Chapter 4, The resolution. Same for code. Write your file structure, function names, buttons, UI areas with no working logic yet. Puzzle piece example: calculator app, dummy version. Let's say you're building a calculator. Write this first. HTML calculator 1 2 plus equals. It does nothing. But you can see the flow. Then build logic later in JavaScript. Gear dummy code in backend. Suppose you're building a login API in Node.js. JS app post /login req res equals / todo validate user res.send. Login logic goes here. It doesn't log in anyone, but it tells you where logic will go. Brick benefits of dummy code. White heavy checkmark breaks your problem into parts. White heavy checkmark reduces pressure to write perfect code. White heavy checkmark helps you stay organized. White heavy checkmark makes collaboration easier. Others can see the structure. White heavy checkmark: you can test layout without backend logic. Fire tip: use to do comments. In your dummy code, add JS / todo, connect to database / todo, validate form / todo, display error message. These are reminders. When I code big apps, my screen is full of todos. One by one, I turn each into working code. Package dummy code with functions. When I start a feature, I create empty functions. JS function validate input / todo, add validation logic function login user / todo, connect to database. This way, I divide logic early even before I implement anything. Hammer and wrench: why beginners should do this. Most beginners try to write everything at once. They mix logic plus UI plus backend. Get stuck when one thing breaks. Panic when nothing works. Dummy code isolates the problem and gives you confidence. Brain think like this: I'll write all parts first even if they do nothing and connect them later. Clipboard recap. Start your projects with dummy code. Dummy code sets up the structure, not logic. Use todo comments to plan features. Empty functions help you stay modular. Dummy code gives you confidence and a clear path forward. 9. Test your assumptions like a detective. Programming is 90% debugging and 10% proving yourself wrong. You might think the code is wrong. But often, your assumptions are. Brain, what are assumptions? Assumptions are the things you believe are working, but never tested. In coding, they're deadly. Let's look at some real examples. Warning example: you think the button works. You click a button and expect an alert. Nothing happens. You assume the button is connected. The function is running. The alert should fire. But did you test each of those things? Probably not. Man detective test like a detective. Detectives don't assume anything. They gather proof. Programmers must do the same. Break your assumptions into pieces. Is the event listener connected? Is the function being called? Is the output what you expect? Test one at a time. Magnifying glass tilted left: how I test assumptions. Whenever something doesn't work, I do this. jsconsole.log, step 1. Then jsconsole.log, step 2. Then jsconsole.log, step 3. Wherever it stops, that's where the error is. This is called step logging. Test 2. Build a truth chain. Every program is a chain of logic. Like this. Rust input dash process dash output. If something fails, don't guess. Test each link in the chain. Is the input correct? Is the process happening? Is the output what it should be? This is debugging by isolation. Hammer and wrench tools for testing assumptions. Console.log, most basic and powerful. Network tab, check if API is even called. Breakpoints, pause code and inspect state. Alerts, quick sanity check. Try/catch, catch errors and display them. Brain, think like a detective. Here's how a detective programmer thinks. Ordinary coder, detective coder. Why doesn't this work? What do I know for sure? It should be fine. Let's test and see. Maybe this is broken. Prove this part is working. Puzzle piece example case: login not working. You write a login form, but login fails. You assume the form submits. The backend receives the request. The database checks credentials. The user is logged in. You test each. White heavy check mark form submits. White heavy check mark backend is hit. White heavy check mark query runs. White heavy check mark session is stored. Now you know where it fails. This is logic, not guessing. Fire pro tip: talk to yourself. When I debug, I talk aloud. Okay, I click the button. Is this function called? Yes. Now what happens? Oh, this returns null. Why? This helps me stay focused. You'll be surprised how often you find the bug just by narrating it. Collision: the danger of untested assumptions. Here's what happens when you skip testing. You change 5 things at once. Something breaks. You don't know which change caused it. You waste hours. Test each piece, one at a time. DNA test like science. Programming is applied science. In science, you have a hypothesis. Run an experiment. Record the result. Draw a conclusion. Do the same with bugs. Don't say I think. Say I know. Clipboard recap. Most bugs come from wrong assumptions. Test like a detective, piece by piece. Use console.log or breakpoints to find where it breaks. Verify every link in your logic chain. Don't fix 5 things at once, isolate and test. 10. How to train your brain to think like a programmer. By now, you've learned that logical thinking is a skill, not a gift. It's something you can train, just like a muscle. But how exactly do you train your brain to think like a programmer? In this chapter, we'll break it down into simple, realistic habits that anyone can follow no matter their background. Brain 1. Start with patterns, not code. Every programming problem follows a pattern. But beginners often jump into writing code without recognizing the structure first. Direct hit example. Let's say you want to remove duplicate items from a list. Before writing any code, ask, what do I already know about the problem? Have I seen something similar before? What steps must happen in order? By thinking in patterns, your brain starts grouping problems logically. With time, you'll instinctively recognize, this is a filtering problem, or this requires counting. To break down the problem, even the easy ones. You can't solve what you can't understand. So, train your brain to slow down and break everything into steps even if the problem seems simple. Hammer and wrench real-world example. Problem: check if a number is prime. Instead of guessing or searching online, break it down. A prime number is only divisible by 1 and itself. So I need to check all numbers between 2 and the number itself, 1. If any number divides it evenly, it's not prime. Then turn that logic into code. Practicing this step-by-step habit sharpens your brain like a sword. Puzzle piece 3. Solve puzzles daily, no coding needed. Your brain thrives on practice but not just from coding. Try spending 15 minutes daily on logic puzzles, Sudoku, chess tactics, brain teasers. These exercises build the same parts of your brain responsible for pattern recognition and decision making, which are core to programming. White heavy checkmark tip: use apps like Elevate, Lumosity, or websites like https://brilliant.org for interactive logic training. Test tube 4. Predict before you run code. Make this a daily habit. Before you run a single line of code, predict the output. Why? Because guessing trains your brain to analyze logic before testing. If you're wrong, great, you'll learn why, which builds a deeper understanding than just reading or watching tutorials. Brick 5. Embrace debugging as brain training. Many people hate debugging. But honestly, debugging is when you learn the most. Every error message is your brain saying, I had an assumption, and it was wrong. Let's fix it. Don't avoid errors, use them. Challenge yourself to solve a bug before searching online. You'll improve your patience, attention to detail, ability to spot patterns and mistakes. Counterclockwise arrows button 6. Teach others, even if you're still learning. Explaining your logic out loud forces your brain to reorganize the idea clearly. You don't need to be an expert. Just try. Writing blog posts. Posting breakdowns of problems you solved. Talking through code with a friend. The act of teaching transforms a vague understanding into concrete knowledge. Person in lotus position 7. Stay calm and think first. When stuck, don't panic. That shuts down your logical brain. Instead, step away for 5 minutes. Reread the problem slowly. Draw diagrams or write it on paper. Calm minds solve problems faster. That's not motivation fluff, that's neuroscience. Lightbulb final thought. Programming isn't magic. It's a way of thinking. And just like any skill, guitar, chess, speaking a new language, the only way to improve is through deliberate practice. You don't need to be a genius. You just need to train your brain, one thought at a time. 11. Debugging as a logical process. Imagine this: you've spent hours writing what you think is perfect code. You hit run, and it doesn't work. Or worse, it works but gives the wrong result. Frustrating, right? Here's the good news: debugging is not a punishment. It's part of logical thinking. Every great programmer, from beginners to professionals at Google or Microsoft, spends hours debugging. But the ones who succeed treat it as a skill, not a setback. Brain, what is debugging? Debugging means finding and fixing the logical or syntactical errors in your code. Sometimes it's a missing semicolon. Other times, it's a flawed approach. There are two types of bugs. Syntax errors, your code doesn't even run. Like forgetting a, or dot. Logical errors, the code runs, but the output is wrong because your thinking is flawed. Hammer and wrench debugging is not guessing. A beginner might do this. Change a few random lines. Add more if statements. Keep refreshing the browser or rerunning the program, hoping something clicks. That's guessing, not debugging. A logical approach is: understand what should happen. See what is actually happening. Find the difference. Trace back to the mistake. Detective real debugging example. Let's say you write this simple code to add two numbers. Python a equals input, enter number 1, b equals input, enter number 2, print, sum is, a plus b. You run it and enter 5 and 10, but the output is sharp sum is 510. Why? Use logic. What's the expected behavior? Add numbers, 5 plus 10 equals 15. What's the actual result? 510. They're being joined, not added. What's the cause? Input, return strings, so you're doing string concatenation. What's the fix? Convert inputs to integers. Corrected code. Python a equals int, input, enter number 1, b equals int, input, enter number 2, print, sum is, a plus b. Wrench tips for debugging logically. Print everything. Print variables at every step to see what's going wrong. This is called tracing your code. Break big problems into small ones. Test each small part separately. Don't try to debug an entire app in one go. Use a rubber duck. Talk through your code out loud, even to a toy duck. It helps you notice logic gaps. Ask yourself, what should this line do? If it's not doing that, why? What's different? Read error messages carefully. They often tell you exactly where the problem is. Don't ignore them. Light bulb exercise. You write this code. JavaScript let x equals 5, if x equals 10, console.log, x is 10. It prints x is 10 even though x was 5. Why? Answer. You used equals instead of equals equals. You're assigning 10 to x, not comparing. Corrected. JavaScript if x equals 10. Checkered flag conclusion. Debugging isn't just about fixing typos. It's about thinking step by step. What did I expect? What happened? Why? What changed? By debugging logically, you build patience, clarity, and the confidence to face any error, not with panic, but with process. 12. The pattern behind every problem. Have you ever looked at a programming question and thought, I've never seen this before, how do I even start? Here's a secret: every problem in programming hides a pattern. And when you learn to recognize patterns, you don't just solve that one problem, you unlock the key to solving all problems. Puzzle piece. What is a pattern? A pattern is something that repeats. In coding, it's the structure or approach that can be used to solve multiple types of problems. Example. Think of a simple problem. Find the largest number in a list. Even if the question changes to find the longest word in a list. Find the student with the highest marks. Find the item with the highest price. The pattern is the same. Start with an initial value, usually the first item. Loop through the list. Compare each item to the current best. Replace if it's better. Done. Repeat button. Common logical patterns in coding. Let's uncover some patterns that exist in every programming language. 1. The counting pattern. You want to count how many items match a condition. Example, count how many numbers are greater than 10 in a list. Python copy edit count equals 0 for number in 5, 12, 20, 8, if number 10, count plus equals 1 print, count, hashtag output, 2. 2. The accumulation pattern. You want to add or build something step by step. Example, calculate the sum of numbers. Python copy edit total equals 0 for number in 1, 2, 3, 4, total plus equals number print, total, hashtag output, 10. 3. The selection pattern. You pick one item based on a rule. Example, find the student with the highest score. Python copy edit students equals, Ali, 80, Sarah, 92, Ahmed, 85, top underscore student equals students 0 for student in students, if student 1 top underscore student 1, top underscore student equals student print, top underscore student, hashtag output, Sarah, 92. 4. The transformation pattern. You want to change items into a new form. Example, convert a list of numbers to their squares. Python nums equals 1, 2, 3, 4 squares equals for number in nums, squares dot append, number asterisk number, print, squares, hashtag output, 1, 4, 9, 16. Magnifying glass tilted left recognizing patterns in problems. Let's practice. Problem. You are given a list of numbers. Find the second largest. You may think this is unique, but it's actually a selection pattern. Step by step. Find the largest. Remove it, or ignore it. Find the largest again, rightward arrow, this is the second largest. Direct hit. Why patterns matter. They save time, you don't need to start from zero. They reduce fear, you've seen it before, just in a different form. They build mastery, master patterns, and you master logic. Brain pattern recognition exercise. You have this problem. Print all even numbers from 1 to 50. Which pattern is this? White heavy check mark. It's selection plus transformation. You're selecting numbers that are even and transforming a range into output. Checkered flag. Conclusion. Every complex code you see, no matter how scary, is built from simple logical patterns. Once you learn to spot them, you'll never feel lost again. Remember, logic is not about memorizing answers. It's about recognizing patterns, step by step. 13. The logic of problem solving, step by step. Programming is not just about writing code, it's about solving problems. Whether you're building a web app, fixing a bug, or creating an algorithm, you're solving a problem. And like math or puzzles, there's a logical method behind it. This chapter focuses on how you can approach any problem systematically, break it into parts, and solve it like a pro. Brain. Step 1, understand the problem. Before writing any code, read the problem carefully. If you don't understand the question, you can't solve it. Ask yourself, what is the input? What is the expected output? Are there any constraints, like performance, memory, or edge cases? What are some examples? Example. Problem, write a function that returns the maximum number from a list. Input, 3, 9, 2, 4. Output, 9. Seems easy, but what if the list is empty? The list contains negative numbers. The list is very large. Magnifying glass tilted left. Step 2, break the problem down. Big problems become small problems if you divide them. Example. If you're building a login system, accept username/password input. Validate credentials. Check against database. Show success or error message. Each step can be written, tested, and debugged individually. Writing hand. Step 3, write a plan in plain English. Before jumping into code, write what you'll do step by step. Example. To find the max number in a list. Start with the first number as the max. Go through each number in the list. If a number is bigger than the current max, update the max. Return the max at the end. This helps you clarify your logic before dealing with syntax. Laptop computer Step 4, convert the logic into code. Once the plan is ready, code it. Python def find _max, nums if not nums, return none #handle empty list max _number equals nums 0 for number in nums, if number max _number, max _number equals number return max _number. Clean and based directly on the plan. White heavy check mark Step 5, test with examples. Run your code with different test cases. Python print, find _max, 3, 5, 1, number 5 print, find _max, -1, -5, -3, #-1 print, find _max, #none. Always test. Normal cases. Edge cases, empty list, one item, etc. Extreme input, big list. Hammer and wrench Step 6, debug and improve. Did the code fail somewhere? Don't panic, walk through your logic again. Use print statements or a debugger. Python print, f checking, number, current max, max _number. Maybe add optimizations later, or make it reusable. Rocket Step 7, reflect and learn. After solving, could you do it faster? Is the code clean? What would you do differently next time? Every problem teaches you something. Even solving it the wrong way improves your understanding. Lightbulb real-world mindset, think like a developer. When you're working on real projects, the problem might not be clear up front. Example. The website is slow. That's not a coding task, that's a problem. Break it down. Is the server slow? Are API calls delayed? Is the JavaScript too heavy? Is there unused CSS or media? Apply the same logical thinking step by step, just like you would with a code problem. Counterclockwise arrows button summary of the 7 steps. Step action. 1. Understand the problem. 2. Break it into parts. 3. Write a plan in plain English. 4. Translate the plan into code. 5. Test your code with cases. 6. Debug and improve. 7. Reflect on what you learned. Test tube, try this yourself. Pick a basic problem like reversing a string, counting vowels, building a calculator. Apply each of these 7 steps. You'll see your thinking becomes clearer and your code becomes better. Remember, great programmers aren't those who know the most, they're the ones who solve problems best. 14. Know when to ask for help. Programming is often seen as a solitary activity, where developers silently wrestle with lines of code until everything magically works. But here's the truth, even the best developers ask for help, and knowing when to do so is a skill, not a weakness. Asking for help at the right time can save you hours, or days, of frustration. This chapter is about developing the emotional intelligence and timing to recognize when it's time to stop spinning your wheels and ask for guidance. Brain: why we hesitate to ask for help. Fear of looking inexperienced. Many programmers worry they'll seem dumb or junior if they admit they're stuck. Desire to solve it alone. There's a pride in solving problems solo. That's great, but not if it leads to wasted time. Imposter syndrome. You might think, everyone else gets it, why don't I? You're not alone. Most people feel this at some point. But remember, asking questions shows you're engaged, curious, and serious about solving the problem. 4 o'clock when to ask for help. Use the 15-30-minute rule. If you've been stuck on a single issue for more than 15 to 30 focused minutes without any meaningful progress, it's time to ask for help. You should also ask when you don't understand the problem or requirements. You're blocked by unfamiliar tools, libraries, or frameworks. You've searched online but only found vague or irrelevant answers. You've narrowed down the bug but can't trace the cause. Toolbox: how to ask for help, the smart way. Don't just say it's not working. Instead, provide what you're trying to do, what you've already tried, the error/output/result you're seeing, relevant code snippets, your thought process. Example: bad ask. My code won't work. Can you help? Example: good ask. I'm trying to reverse a string in C#. I used a for loop and appended characters to a new string, but I'm getting an index out of range error. I tried adjusting the loop bounds, but no luck. Here's my code. This shows effort, and the helper is more likely to assist quickly and respectfully. People holding hands: where to ask. Your peers or mentors. Team leads or senior developers. Online forums like Stack Overflow, Reddit's r/learn programming, GitHub discussions. Communities like Discord servers, Twitter dev threads, or dev.to comments. Bonus: if you're in a coding bootcamp or university course, make use of teaching assistants or Slack channels. Direct hit: the long-term benefit. The more you ask smart questions, the faster you learn. Over time, you'll start spotting patterns. You'll solve similar issues on your own. You'll eventually become the person others ask. Puzzle piece: real-world example. Scenario: you're working on a web app using React. A bug causes the page to re-render infinitely. You try use effect, use memo, console.log, and nothing helps. After 25 minutes, you ask a senior dev. They look for 2 minutes and say, you forgot to add a dependency array in use effect. Lesson: you just saved hours of pain by asking. Memo exercise. Next time you're stuck, set a timer for 20 minutes. Try everything you can think of. Write down your problem clearly. Ask someone or post it online the right way. You'll be surprised how fast things move when you're not alone. End arrow summary. Asking for help isn't a weakness, it's a superpower when used wisely. It's what separates the stuck from the stuck but learning. The smartest developers know when to stop guessing and start collaborating. 15. Google like a developer. From frustration to solution, the art of effective searching. Imagine this: you're stuck on a bug, and your code just won't work. You've tried for hours, but nothing seems to fix it. You open Google, type in code not working, and the results are useless. Why? Because Googling like a developer is a skill, not just something you do. In this chapter, you'll learn how to search the way real developers do, strategically, efficiently, and smartly. You'll turn Google, Stack Overflow, GitHub, and documentation into powerful tools that guide your learning and problem solving. Magnifying glass tilted left: why Googling is a superpower. Every developer, no matter how experienced, uses Google. But the difference between beginners and professionals lies in how they search. Bad example: my code is broken, please help. Good example: JavaScript uncaught type error, cannot read property length of undefined in for loop. The second query is specific, technical, and keyword rich, increasing the chance of finding the exact solution you need. Brain step by step: how to Google like a developer. 1. Use the exact error message. If you get an error like bash type error, cannot read properties of undefined, reading map, copy the whole message and paste it into Google. Add your language or framework, like React or Node.js, to narrow results. White heavy checkmark type error, cannot read properties of undefined, reading map, React. 2. Use keywords, not sentences. Instead of typing, how do I fix my code when it doesn't work in JavaScript? Try JavaScript function undefined return value. This works better because search engines are optimized for keywords, not stories. 3. Add context. Include your language, framework, and tool names. Python Flask post request 400 error. C# SQL connection string timeout error. 4. Use quotes and operators. Use quotes to search for exact phrases. Unexpected token in JavaScript. Use cite operators. Cite StackOverflow.com array index out of range Python. This limits results to Stack Overflow. White heavy checkmark advanced search tips. Technique example. Exact phrase. Index out of range. Exclude terms. JavaScript array error TypeScript. Search only one site. Cite github.com upload file PHP. Combine terms logically. CSS grid layout or flexbox responsive. Target documentation. Cite developer.mozilla.org local storage. Lightbulb real-world example. Let's say you're building a login form in PHP and get this error. Bash warning, undefined array key username. Bad query. Login form doesn't work. Good query. Undefined array key username PHP login form. Better query. PHP warning, undefined array key username on post request. Now you'll likely land on a Stack Overflow thread explaining how to check if $_post username is set before accessing it. Prohibited what not to do. Don't paste your entire code into Google. Don't use vague words like broken or weird error. Don't expect one-click solutions. Always read and understand answers before applying them. Wrench tools to level up. Stack Overflow, great for Q&A. GitHub, see how others solved similar issues. DevDocs, fast documentation across languages. Reddit, r/learn programming, community discussions. MDN Web Docs, trusted source for web technologies. Speech Balloon personal tip. When I was learning React, I would keep getting errors like cannot update a component while rendering a different component. Instead of panicking, I Googled React cannot update a component while rendering a different component. From the results, I found an official GitHub issue thread and learned what caused it rendering state updates during another render phase. That changed how I approached re-renders forever. Puzzle piece final thoughts. Googling like a developer isn't about searching more, it's about searching smarter. The internet is your debugging assistant, your mentor, and your library. You just need to know how to talk to it. Master this skill, and you'll never be stuck for long. White heavy checkmark key takeaway. Google won't give you answers unless you ask the right questions. Learn to speak the language of developers, search precisely, read deeply, and grow continuously. 16. Test with edge cases. The bugs hide where you never thought to look. Why edge cases matter. Once your code runs successfully for a typical input, you may feel done. But software doesn't break during typical use, it fails at the edges. That's why edge case testing is one of the most powerful tools in a programmer's toolkit. Edge cases are inputs that are at the minimum or maximum boundaries, are empty or null, are unusually large or small, break common assumptions. If you don't test these, your program might work 95% of the time but fail critically when it matters most. Common types of edge cases. Let's go over common edge case categories and how they appear in real-world coding problems. 1. Empty inputs. Strings, empty string. Arrays, empty array. Objects, empty object. Input fields, no value. Example. Function to count characters in a string. JS function charCount, str, return str length. What if str is empty? Will your function still behave as expected? 2. Null or undefined. Sometimes, you'll forget to validate if a value exists. JS function getUserAge, user, return user.age. If user is null, this will crash with cannot read property age of null. White heavy check mark always check for existence. JS if, user and end user.age, return user.age. 3 very large inputs. Say you built a search algorithm. It works fine with 10 or 100 items. But what about 1 million? Try this. JS let big array equals new array, 1 underscore 0 0 0 underscore 0 0 0, dot fill, 1, my search function, big array, 1. Is your function still efficient? Or does it freeze the browser or timeout? 4 negative numbers. If a function expects a count or index, what happens when a negative value sneaks in? JS function getIndex, arr, I, return arr getIndex, 1, 2, 3, -1, / unexpected output, 3 in some languages. Some languages allow negative indexing, others don't. Edge behavior varies. 5 special characters or types. Input like, @$, emojis, or nan can break assumptions. Always sanitize inputs. Real example, password validator. Suppose you write a password validator. JS function is valid password, pwd, return pwd.length equals 8 and pwd.includes. Edge cases. Empty cross mark. 1 2 3 4 5 6 7, 2 short cross mark. 1 2 3 4 5 6 7 8, no special char cross mark. 1 2 3 4 5 6 7 8. White heavy check mark. You've now tested all relevant edge boundaries. How to think in edge cases. When writing tests, ask. What happens if I give 0 items? What if I give a huge number? What if it's the wrong type? What if it's null or undefined? What if it's almost correct? This mindset makes your code bulletproof. Pro tip, write unit tests. If you use tools like Jest, Mocha, or JUnit, include edge case tests in your test suite. JS test should return false for empty string, equals expect, is valid password, .tob, false. Final words. Writing code is only half the battle. The real victory comes when it survives unexpected input and still performs well. That's what separates an average coder from a reliable developer. Test with edge cases. Trust me, it'll save your day and night. 17. Write reusable solutions. Don't repeat yourself. Scale yourself. What does it mean to write reusable code? Reusable code is modular, adaptable, and scalable. It's the kind of code you can write once and use in many places without rewriting it. Instead of solving the same problem every time it appears, you abstract the logic into functions, classes, or modules and reuse them like tools in a toolbox. Why reusability matters. Think about this. Prohibited you write the same input validation in 4 different files. Prohibited you format dates manually again and again. Prohibited you hardcode logic that could work for many inputs. Then later, you discover a bug, and now must fix it 4 times. You need to update the format in every file. You realize your code is becoming a copy-paste mess. Reusable code equals single source of truth. Fix it once, use it everywhere. How to write reusable solutions. White heavy check mark 1. Abstract logic into functions. If you use the same logic more than once, wrap it in a function. Before, repetitive. JS copy edit const price 1 equals item 1 dot price asterisk 1.18, const price 2 equals item 2 dot price asterisk 1.18. After, reusable. JS copy edit function apply tax, price, rate equals 0.18, return price asterisk, 1 plus rate, const price 1 equals apply tax, item 1 dot price, const price 2 equals apply tax, item 2 dot price. White heavy check mark 2. Make components generic. Avoid making functions too specific to one context. Too specific. JS copy edit function get user age from Facebook, FB user, return FB user.details.age. Reusable. JS copy edit function get user age, user, return user.details.age, null. Now it works for any kind of user object. White heavy check mark 3. Parameterize your functions. Let callers customize behavior through arguments. Bad. JS copy edit function get welcome message, return hello, John. Good. JS copy edit function get welcome message, name equals user, return hello, $name. White heavy check mark 4. Avoid hard coding. Hard coding data makes functions rigid. Instead, pass data as arguments or read from config files. White heavy check mark 5. Organize with modules or utilities. Group similar reusable functions together. Bash copy edit file folder util/math.js string.js date.js. Now you can import only what you need. JS import capitalize from ./util/string.js. Real example, a string formatter utility. JS//util/string.js export function capitalize, str, return str char at, 0, to uppercase, plus str slice, 1, export function truncate, str, length equals 50, return str length, str slice, 0, length, plus, str. Now, in multiple parts of your app. JS import capitalize, truncate from ./util/string.js, capitalize, hello, //hello truncate, this is a very long sentence, 10, // this is a. Reusable code is also testable. Because reusable functions are small and focused, they're easier to test. Write unit tests for each function. Now, any file that uses them inherits those guarantees. Final advice. Don't hard code values or assumptions. Keep your functions small and focused. Think, can I use this somewhere else? Favor composition over duplication. Quote to remember. Code is read more often than it is written. Write it for humans first, machines second. Reusable code saves time, reduces bugs, and makes you a stronger developer. Start small, extract functions, organize them, and think in building blocks. 18. Use version control early. Imagine building a tower of blocks. Every time you add a new block, there's a chance the tower might tumble. Now, what if you had a magical undo button that could return the tower to a stable state anytime something went wrong? That's what version control gives to developers. What is version control? Version control is a system that records changes to your code so that you can revisit, compare, or revert to earlier versions. The most widely used version control system today is Git, and platforms like GitHub, GitLab, and Bitbucket make collaboration easier with cloud storage and team features. Think of Git as a time machine for your code. Made a mistake? Go back. Added a feature that broke things. Revert it. Want to try a wild experiment without risk? Create a branch. Why start early? Most beginner developers only think about version control when working on large projects or collaborating with others. But the truth is, you should start using it from day one even when you're just practicing on small scripts. Here's why. Safety net, if something breaks, you can roll back. Experiment freely, try out new ideas on branches without affecting the main project. Learn the workflow, starting early makes version control second nature later. Track your progress, you'll see how your thinking and solutions evolve. Portfolio power, sharing your repos shows your growth and discipline to potential employers. How to use Git, basic workflow. Initialize your repo bash git init. Add files bash git add. Commit changes bash git commit m initial commit. Create a branch bash git checkout b feature cool stuff. Merge branch bash git checkout main git merge feature cool stuff. Push to GitHub bash git remote add origin https://github.com/username/repo.git push u origin main. Example, how Git saved the project. Zara was working on a student attendance system. She added a few features on Friday night but forgot to test one module. On Saturday, everything broke. Thankfully, she had used Git. She reverted to the last working commit and made the fix without panic. Had she not used version control, she might have lost hours or the entire project. Common pitfalls to avoid. Committing too little, don't save only at the end. Commit logically and often. Not writing messages, your commit history should tell a story. Ignoring .gitinery, keep your repo clean from unwanted files. Pro tip, create a habit. Commit at least once a day. Always pull the latest code before pushing. Use branches for each new idea or feature. Summary. Using version control from the beginning of your coding journey will not only make your work more stable and recoverable, it will also prepare you for real-world software development workflows. Don't wait for a big project. Start small, but start now. Git is your safety net, your history log, and your roadmap all in one. 19. Handling time and space complexity simply. When you start solving problems, it's easy to focus only on getting the correct answer. But as your programs grow, efficiency becomes crucial. That's where time and space complexity come into play. Let's break this down without fancy jargon, just practical understanding. What is time complexity? Time complexity tells you how long your algorithm will take to run based on the size of the input. It's not about actual seconds but about how your code scales. Imagine you have a list of 10 names. Your program takes 1 second. Now with 1000 names, it takes 100 seconds. That's a clue your algorithm is scaling poorly. This growth is usually written in big O notation. Big O notation, what it means. Example. O, 1. Constant time. Accessing an array item. O, n. Linear time. Looping over an array. O, n superscript 2. Quadratic time. Nested loops. O, log n. Logarithmic time. Binary search. What is space complexity? Space complexity tells you how much memory your program uses based on input size. For example, storing a list of 1000 items, O, n. Using just one variable, O, 1. Even if your algorithm is fast, it might crash if it uses too much memory. Efficient code means being mindful of both time and space. Why should you care? Let's say you're building a search tool for millions of users. If your code runs in O, n superscript 2, it might work on test cases, but it'll freeze in production. This is why every skilled developer must understand and optimize complexity. Simple example. Let's find the maximum number in a list. Python def find _max, nums max _number equals nums 0 for number in nums, if number max _number, max _number equals number return max _number. Time complexity, O, n, rightward arrow it checks every element once. Space complexity, O, 1, rightward arrow it uses just one extra variable. Efficient and clean. Bad vs good example. Inefficient, O, n superscript 2. Python for I in range, len, arr, for j in range, len, arr, if arri equals arrj, hashtag do something. Better, O, n. Python scene equals set, for val in arr, if val in scene, hashtag do something scene.add, val. By using a set, which allows fast lookups, you reduce time complexity drastically. Practical tips. Always think about input size. Will this code still work with 1 million entries? Avoid unnecessary loops or recursion. One clean loop, multiple nested ones. Use better data structures. Sets and dictionaries often beat lists. Space-time trade-off is real. Sometimes you use more space, like a hash map, to save time. Visualizing complexity. Input size, n, o, 1, o, log n, o, n, o, n superscript 2. 10 white heavy check mark, white heavy check mark, white heavy check mark, white heavy check mark. 1000 white heavy check mark, white heavy check mark, white heavy check mark, grimacing face. 100,000 white heavy check mark, white heavy check mark, warning cross mark. 1,000,000 plus white heavy check mark, grimacing face skull. Summary. Time and space complexity help you write code that works not only today but when the project scales. You don't have to become a mathematician, just build the habit of asking yourself, can this be faster? Can I use less memory? Small changes can mean huge improvements. 20. Build your own problem-solving framework. Every great programmer eventually develops their own way of solving problems. Think of it like a personal algorithm, a repeatable process that works for you, speeds up your thinking, and boosts your confidence in tackling any challenge. This chapter guides you to create your own problem-solving framework. It's a system tailored to how you think, combining logic, habits, and structure. Once built, this becomes your toolkit to tackle bugs, build systems, and stay unstuck. Magnifying glass tilted left. Why you need your own framework. When we start coding, we rely heavily on tutorials, documentation, or Stack Overflow. Over time, you notice patterns in your thinking, how you approach a problem, how you debug, how you structure your solution. That pattern becomes your framework. Without one, problem solving feels chaotic. With one, it's organized and repeatable. Brain example framework, you can start with. Let's walk through a basic version of a framework you can adopt, adapt, and expand. 1. Understand the problem clearly. Rephrase it in your own words. Ask, what is really being asked? Example. If the problem is check if a number is prime, restate it, I need to return true if a number has no divisors except 1 and itself. 2. Define inputs and outputs. Write out a few examples, test cases, or edge cases. Example. Input, 5 rightward arrow output, true. Input, 6 rightward arrow output, false. Input, 1 rightward arrow output, false. 3. Think through the logic before writing code. Use pseudocode, a flowchart, or just comments. Example. PGSQL // check if number is less than 2 rightward arrow false / loop from 2 to sqrt, number, / if divisible rightward arrow false / else rightward arrow true. 4. Code incrementally, one step at a time. Don't try to build the whole solution at once. Focus on one part, test it, then move forward. 5. Test with basic and edge cases. Validate your code with small, weird, and large inputs. 6. Optimize only if necessary. Don't prematurely optimize. First get it working, then improve efficiency if needed. 7. Reflect and save the solution. Once it works, reflect. Could I have written it better? Did I overcomplicate? Can this solution help in future problems? Save the solution in your personal notes, GitHub repo, or portfolio. Toolbox customize it for you. You can build your framework using bullet points, checklists, flowcharts, mind maps, a Notion template, a PDF you keep open when solving problems. The important thing is that it becomes second nature over time. Rocket real-life analogy. Think of a chef's workflow: prep, cook, taste, serve. A photographer: plan, shoot, review, edit. A pilot: checklist, take off, monitor, land. Likewise, a developer's framework becomes their cockpit. It ensures no steps are skipped and helps you fly smoothly even in turbulence, bugs, errors, deadlines. White heavy check mark your turn, start building. Here's a template to start with, you can edit this later. Restate the problem. List sample inputs/outputs. Write logic in plain English. Write pseudocode or comments. Implement small parts. Test thoroughly. Reflect and record. Start using this template for every problem you solve for the next 7 days. You'll begin to internalize it and evolve it naturally. Quote to remember. Discipline is just choosing between what you want now and what you want most. Abraham Lincoln. Your framework is the discipline that keeps your logic focused, your code clean, and your stress low. 21. Real-world problem walkthrough. One of the best ways to truly understand how to solve programming problems is to walk through a real-world example from start to finish. In this chapter, we'll dissect a problem that mirrors what you might face during interviews, coding competitions, or actual software development. We'll demonstrate the logical steps behind solving it, not just throwing code at it, but approaching it with strategy and clarity. Puzzle piece problem statement. Build a to-do list CLI app with the following features. Add a new task. List all tasks. Mark tasks as complete. Delete tasks. Save tasks in a file. This may sound simple, but it requires file handling, logic for operations, and user interaction. Brain step-by-step thinking. 1. Understand the requirements. Don't code yet. Think. What do users need? A menu to select actions. Tasks must persist after closing the app. Rightward arrow. Use a file. Each task needs ID. Description. Completed status. 2. Break down the features. Turn requirements into logical modules. Show _menu. Add _task, description. List _tasks. Complete _task, task _ID. Delete _task, task _ID. Save _tasks, /load _tasks. Each function solves a small part of the big problem. Abacus. Drafting the structure, pseudocode. Python. While true, show _menu, choice equals input, enter choice, if choice equals 1, add _task, if choice equals 2, list _tasks, if choice equals 3, complete _task, if choice equals 4, delete _task, if choice equals 5, break. This loop lets users interact with your app. Now fill in the functions. Floppy disk file handling example. Python def save _tasks, tasks with open, tasks.text, w, as f, for task in tasks, f.write, f task id, task description, task done \n. Simple CSV style storage. The goal is to make logic work first before optimizing. White heavy check mark logic to mark a task as complete. Python def complete _task, tasks task _id equals input, enter task id to mark complete, for task in tasks, if task id equals task _id, task done equals true, print, task completed. Return print, task not found. Repeat button. Review and refactor. Once you get a working prototype, make it modular, reusable code. Handle edge cases, empty file, duplicate IDs. Improve UI/UX, clear messages. Graduation cap. What you learned. How to apply logic to dissect a real-world problem. How to use functions to create readable, maintainable code. How persistence, file storage, fits into problem solving. Checkered flag takeaway. The best logic isn't about complexity, it's about clarity and purpose. Solving a real-world problem is like solving a puzzle. You observe, break it down, tackle one piece at a time, and then bring it all together. 22. Common logical mistakes developers make. Even experienced developers can fall into logical traps. These mistakes may not always throw errors but can make your program behave incorrectly or worse, subtly wrong. In this chapter, we'll explore the most common logical pitfalls developers make and how to avoid them with disciplined thinking. Brain 1. Assuming input is always valid. Mistake. Assuming the user will enter a number when asked. Why it fails. If the user types hello instead of 5, your program crashes or behaves unpredictably. Fix. Always validate input. Python try, number equals int, input, enter a number, accept value error, print, please enter a valid number. Repeat button 2. Infinite loops. Mistake. Writing a loop that never exits due to wrong conditions. Python I equals 0 while I equals 10, I plus equals 2 hashtag I will never be 10, we'll skip it. Fix. Trace the logic carefully and always test boundaries. Brain 3. Off by 1 errors. Mistake. Loops running one iteration too few or too many. Python for I in range, 1, 10 hashtag ends at 9, not 10 print, I. Fix. Use clear comments and test edge boundaries. Consider. Should the loop be inclusive or exclusive? Should the index start from 0 or 1? Direct hit 4. Misusing logical operators. Mistake. Confusing and, or, and not. Python if x10 or x5, hashtag intended, between 5 and 10? Fix. Understand precedence. Break conditions clearly. Python if 510, hashtag now it's correct. Floppy disk 5. Incorrect assumptions about data types. Mistake. Comparing string 10 with integer 10. Python if input underscore value equals 10, hashtag this will always be false if input underscore value is a string. Fix. Always know what type you're comparing. Counterclockwise arrows button 6. Misunderstanding mutability. Mistake. Assuming copying a list creates a new one. Python a equals 1, 2, 3 b equals ab dot append, 4, print, a, hashtag 1, 2, 3, 4. Fix. Use dot copy, or slicing. Python b equals a, smiley face, bug 7. Silent failures, missing else. Mistake. Leaving out the else when conditions aren't met, assuming code will do nothing. Fix. Always account for the default scenario. Warning 8. Confusing assignment with comparison. Python if x equals 5, hashtag syntax error in Python, but a bug in other languages like JavaScript. Fix. Use equals for comparison and equals for assignment. Sounds simple but causes major issues. Repeat button 9. Recalculating instead of storing results. Mistake. Running expensive calculations repeatedly. Python for I in range, 1 million result equals compute underscore something. Fix. Calculate once, reuse. Bar chart 10. Overcomplicating the logic. Mistake. Trying to write clever, compact one-liners that no one can read. Python result equals x if x y else y if y z else z hashtag hard to read. Fix. Clarity cleverness. Python if x y and x z, result equals x if y z, result equals y else, result equals z. Lightbulb takeaway. Logical bugs are invisible errors. They don't crash your program but make it do the wrong thing. To avoid them, think before you code. Test edge cases. Read code like a user would read instructions. Keep your logic simple, predictable, and traceable. Debugging logic is not about fixing code. It's about fixing thinking. 23. Mindset for consistent growth. A good developer solves a problem. A great developer never stops improving. Brain introduction. Logic and techniques can get you far in programming, but your mindset is what carries you through the long run. The truth is, the world of development changes constantly, new frameworks, tools, and even paradigms appear regularly. The most successful developers are not just good at solving problems, they're lifelong learners who continuously evolve. This chapter dives into the mindset that ensures you grow consistently, no matter your current level. Key 1. Adopt a growth mindset. The idea of a growth mindset was made popular by psychologist Carol Dweck. Here's how it applies to programmers. Fixed mindset. Growth mindset. I'm not good at algorithms. I can improve my algorithm skills with practice. This error is too hard. This is tough, but I'll learn something from solving it. Why it matters. Believing you can improve changes how you tackle problems. You become more persistent, curious, and open to feedback. Counterclockwise arrows. Button 2. Reflect regularly. After solving a bug or building a feature, take 2 minutes to ask yourself, what did I learn? What could I do better next time? Did I waste time? If so, where and why? Reflection turns experiences into long-term wisdom. Writing hand example. After debugging a UI issue for 3 hours, you realize you didn't check the browser console early on. Next time, you start there, saving time. Books 3. Learn in small bites, not all at once. Instead of trying to master everything in one go, focus on learning one concept a day. Today, closures in JavaScript. Tomorrow, Git rebase vs merge. Next, Big O notation basics. This daily habit compounds over time. In a year, you'll be 365 concepts stronger. Handshake 4. Stay connected with the community. Being part of a developer community, like dev.to, GitHub, Reddit, or Stack Overflow, exposes you to new tools and tricks. Helps you stay current with trends. Encourages you during tough times. Test tube tip: follow a few respected developers on Twitter or YouTube. You'll get inspiration and quick learning from their experiences. Puzzle piece 5. Teach what you learn. When you teach, you reinforce your own understanding. Write blog posts. Create tutorials. Explain a concept to a friend. Even just explaining a bug fix to your rubber duck baby chick counts. Example: you wrote a blog about recursion, and now you understand it way better than you did when just watching videos. Repeat. Button 6. Revisit old code. Looking back at your older code can show how much you've improved. Help you refactor with better logic. Inspire better design patterns. Growth is most visible in comparison. Your past code is a mirror to reflect on. Locked with key final words. Your logical problem-solving skills will evolve only if your mindset supports that evolution. Embrace challenges. Stay curious. Share what you learn. And remember, growth isn't a sprint, it's a habit. 24. How to practice efficiently. Practice doesn't make perfect. Perfect practice makes progress. Rocket: why practice matters. In programming, theory is only half the battle. The other half is doing the work: writing code, debugging, testing ideas. But not all practice is equally valuable. Some developers spend years writing code without improving much because they're not practicing efficiently. This chapter teaches how to practice smarter, so you can sharpen your logical thinking, improve problem-solving skills, and avoid wasted time. Direct hit 1. Focus on intentional practice, not just repetition. Efficient practice is about solving problems with purpose. Brain instead of solving 100 problems randomly. White heavy checkmark. Try solving 20 with focus on a specific concept like recursion or dynamic programming. Set a clear goal for each session. Today I'll improve my use of hash maps. This week, I want to be faster at solving medium-level DP problems. Stopwatch 2. Use the 25/5 technique, Pomodoro. Work for 25 minutes with full focus rightward arrow, then break for 5 minutes. Why it works? Forces concentration. Reduces burnout. Keeps your energy consistent. Hourglass not done example, 4 Pomodoros equals 2 hours of pure practice with breaks. Chart increasing 3. Track what you learn. Make a practice log, physical or digital. Record. Problem name/topic. Difficulty level. What you learned. What you struggled with. This reinforces learning and helps with revision. Memo example. LeetCode 53, maximum subarray. Struggled with Catane's algorithm. Now I know, reset current sum when it's negative. Counterclockwise arrows button 4. Solve the same problem multiple ways. One of the best ways to develop logic is to revisit a problem and solve it differently. Try. Brute force first. Then optimize it. Use recursion, then convert to iteration. Compare time complexities. Brain. This trains your brain to see multiple paths to the same goal. Brain 5. Reflect after each session. Ask. What did I do well? What patterns did I notice? What slowed me down? What will I do differently next time? This transforms raw effort into growth. Test tube 6. Practice under constraints. Set challenges. Solve in under 15 minutes. No Googling until you try for 30 minutes. Use only basic syntax, example no libraries. Why? Constraints create creativity. Example, limiting array methods forces deeper understanding of loops. Book 7. Mix problem types. Don't just grind one topic endlessly. Rotate through. Weak focus. 1. Arrays plus strings. 2. Linked lists plus trees. 3. Recursion plus backtracking. 4. Graphs plus DP. This ensures you develop balanced logic muscles. Busts in silhouette 8. Discuss with others. Practicing alone is fine. But discussing problems with others teaches you new techniques. Shows you different perspectives. Builds your confidence in explaining logic. Pair programming and problem-solving meetups are powerful. Hammer and wrench 9. Build mini projects alongside. Practice logic through real-world mini projects. Todo list with data structures. Maze game, for backtracking. API with pagination, logic plus performance. This ties algorithmic thinking to practical applications. Repeat button 10. Review old mistakes. Every few weeks. Go back to problems you once struggled with. Try solving them from scratch. Measure how much faster/better you are. Seeing progress is fuel for motivation. Puzzle piece bonus, competitive platforms to use. Here are top platforms for efficient logical practice. LeetCode. Codeforces. HackerRank. Exechism.io. Edabit, for beginners. Brain final words. You don't need to solve thousands of problems to become a great logical thinker, you just need to practice consistently and efficiently. Use focus, intention, reflection, and variety. Progress comes not from how much you do, but how well you do it. 25. Interview problem-solving tips. Job interviews are a different kind of programming challenge, one where logic, communication, and confidence all intersect. Whether you're solving a coding problem on a whiteboard, in an online test, or during a live technical interview, the key is to show your thinking process, not just get the right answer. This chapter breaks down how to tackle coding interview problems with confidence, the steps to take, and mistakes to avoid. Brain Step 1, understand the problem, out loud. Interviewer says, write a function to check if a string is a palindrome. What most people do, start coding immediately. What you should do, ask clarifying questions first. Example clarifying questions. Should the palindrome check be case sensitive? Do we consider spaces and punctuation? What's the expected input size? Rocket tip, interviews test your communication. Repeat the problem in your own words to show understanding. Say this. So just to clarify, you want a function that takes in a string and returns true if it reads the same forwards and backwards, ignoring case and punctuation. Gear step 2, think before you code, outline a plan. Don't rush into writing code. Think through the logic. For the palindrome example. Plan. Remove non-alphanumeric characters. Convert to lowercase. Compare the string to its reverse. Say this. First, I'll sanitize the string to remove unwanted characters. Then, I'll convert it to lowercase and compare it with its reverse. This shows logical thinking and preparation. Writing hand step 3, write clean, simple code. Now that you've explained your plan, begin coding confidently but simply. Python example. Python import redef is underscore palindrome, s cleaned equals resub, r caret azaz 0-9, s, dot lower, return cleaned equals cleaned : -1. Pushpin tip, use meaningful names and keep things short and readable. Avoid over-engineering. Test tube step 4, test it yourself, with edge cases. Before the interviewer asks you to test your code, beat them to it. Example cases. A man, a plan, a canal, Panama rightward arrow should return true. Hello rightward arrow should return false. Empty string rightward arrow should return true. Say this. I'll try a few test cases including punctuation and an empty string. Warning: common mistake, not handling edge cases like null/empty inputs, symbols, or numbers. Repeat button step 5, optimize and reflect. Once the function works, talk about efficiency. Time complexity, n, since we process the string once. Space complexity, n, for the cleaned version. If it can be optimized, mention it. If not, confidently explain why this is optimal. Say this. I believe this is optimal since we touch each character once and avoid unnecessary data structures. Lightbulb bonus, use the star format for big questions. For behavioral or open-ended questions like tell me about a time you solved a difficult problem, use situation, task, action, result. Example answer. I once worked on a backend bug causing memory overflow, s. My task was to identify the root cause quickly, t. I profiled memory usage, found a loop with excessive data retention, a, and patched it by limiting the data set, r. The app's memory footprint dropped by 60%. Compass final checklist for any interview problem. White heavy checkmark ask clarifying questions. White heavy checkmark explain your plan first. White heavy checkmark code step by step, out loud. White heavy checkmark test thoroughly. White heavy checkmark discuss time/space complexity. White heavy checkmark keep calm and confident. Sparkle's real interview example, FizzBuzz. Problem, print numbers 1 to 100. For multiples of 3, print fizz, for 5, buzz, for both, FizzBuzz. Process. Clarify, do we print or return an array? Plan, loop 1 to 100 rightward arrow conditionals for 3/5. Code, Python for I in range, 1, 100, and 1 if I%15 = 0, print, FizzBuzz, il if I%3 = 0, print, fizz, il if I%5 = 0, print, buzz, else, print, I. Test it. Explain, it's n, time, 1, space. I used %15 for combined condition. End arrow. In summary, solving problems in an interview is not about perfection, it's about communication, logic, and demonstrating growth mindset. Remember, the interviewer wants to hire someone they can work with, not just a human compiler. 26. Staying motivated through challenges. Let's be honest, problem solving is hard. Sometimes, you'll hit a wall. The code won't work, the logic will feel impossible, and the frustration will pile up. In those moments, staying motivated becomes just as important as any technical skill. In this chapter, we'll look at how to stay resilient, positive, and productive even when the road gets tough. 1. Accept that struggle is part of growth. You're not bad at programming because you're struggling. Every great developer, whether working at Google or building indie games, struggles. The key difference: they learn to see struggle as proof of growth. If it's too easy, you're not learning anything new. Think of every bug, error, or failed test as a mini challenge designed to sharpen your skills. 2. Break the problem down, emotionally and technically. When something feels overwhelming, our brains panic. Instead of trying to solve everything at once, emotionally break it down. Say out loud, "Okay, this part is confusing me." That's fine. Technically break it down, identify smaller parts. Maybe the logic is fine, but the input isn't what you expected. Once you isolate where the problem really is, you take back control, and with it, confidence. 3. Celebrate small wins. Fixed a small bug. Pat yourself on the back. Wrote a cleaner function. Nice. Resisted the urge to give up. Huge win. Most motivation isn't about one big goal, it's about hundreds of little victories. Keep track of them. Celebrate them. 4. Revisit your why. Why are you learning to solve problems? Is it to get a job? Build your dream app? Teach others? Just to prove to yourself that you can? Write that reason down. Keep it near your screen. On hard days, your why can pull you through when your logic fails you. 5. Follow a routine. When motivation disappears, and it will, discipline steps in. Even 30 minutes of focused practice every day is better than cramming 10 hours once a week. Use the Pomodoro technique: 25 minutes work, 5 minutes break. Set up a specific time each day for problem solving. Track your effort, not just your progress. 6. Build a support network. You're not alone. Join developer communities, like dev.to, Reddit's r/learn programming, or Discord. Talk to friends who code. Pair program with someone. Teach what you learn, it'll build your confidence and help others. Even just reading others' struggles and solutions helps normalize your own journey. 7. Take breaks intentionally. Don't confuse burnout with laziness. It's okay to step away. Go for a walk. Switch to a creative task. Play a short game. Your brain often solves problems in the background when you're not looking directly at them. 8. Keep a victory log. Create a simple file or journal entry where you note what problems you've solved. Capture what you learned. Reflect on moments you felt stuck but pushed through. It's motivating to look back and see proof of your evolution. 9. Turn frustration into fuel. When you're frustrated, channel that energy. Say to yourself, "I've come too far to stop. If I solve this, I'll level up. I want to understand this because it makes me powerful." That mental shift, turning emotion into purpose, is a developer's secret weapon. 10. You're not behind. You're on your own path. Ignore comparisons. You don't need to solve 500 LeetCode problems or build a portfolio overnight. Your journey is yours. Your pace is valid. Real life example. Meet Rian. He was stuck on recursion problems for 3 weeks. Every day, he'd get more demotivated. He almost quit. But instead of giving up, he started solving just one problem a day, no matter how simple. After 2 weeks of small wins, recursion clicked. Now he mentors others in it. The lesson? Stay in the game. Even small effort compounds into big results. Summary, tools to stay motivated. White heavy check mark, accept the struggle. White heavy check mark, break problems down. White heavy check mark, celebrate small wins. White heavy check mark, remember your why. White heavy check mark, follow a daily routine. White heavy check mark, lean on community. White heavy check mark, take intentional breaks. White heavy check mark, track victories. White heavy check mark, reframe frustration. White heavy check mark, own your journey. Final thought. Motivation isn't magic, it's momentum. Just keep going. You don't have to be fast. You just have to not quit. 27. Recommended tools and techniques. In the journey of problem solving, tools aren't just accessories, they're amplifiers of your thinking. The right tools and techniques can speed up your process, reveal patterns, catch bugs early, and help you learn more efficiently. In this chapter, we'll cover a set of developer-friendly tools and techniques that are easy to adopt but incredibly powerful in practice. Hammer and Wrench 1. Code editors that work with you, not against you. Choose a code editor that enhances productivity. Visual Studio Code, VS Code, lightweight, extensible, and loaded with smart features like IntelliSense, Git integration, debugger, and extensions for nearly every language. JetBrains IDEs, PyCharm, WebStorm, etc. great for deep language support and refactoring. Sublime Text, very fast and lightweight with powerful shortcuts. Example, use VS Code with extensions like Prettier for formatting, ESLint for JavaScript linting, Code Runner to quickly test snippets, Live Server for web development preview, TestTube 2. Testing frameworks for better confidence. Tests aren't just for production code. Writing tests when practicing problem solving. Catches edge cases. Reinforces your understanding. Gives instant feedback. Popular frameworks. Python, Unitest, Ptest. JavaScript, Jest, Mocha. Java, JUnit. C#, XUnit, NUnit. Example. Python def add, a, b return a plus b def test underscore add, assert add, 2, 3, equals 5 assert add, -1, 1, equals 0. Lady Beetle 3. Debugging tools. Don't fear bugs, embrace them. Learn to use debuggers instead of just print statements. VS Code Debugger, add breakpoints, step through code. Browser Dev Tools, debug HTML/CSS/JavaScript in real time. Postman, test API requests visually with headers and payloads. PDB, Python's built-in debugger for CLI-based code. Books 4. Documentation resources. Great developers are great readers. Use docs often. MDN, for web development, JavaScript, HTML, CSS. DevDocs.io, offline documentation for many languages. ReadTheDocs.org, documentation for Python libraries. Official Docs, for Python, Java, C++, C#, etc. Tip, learn how to search efficiently. Python lists sort by key, site stackoverflow.com. Or JavaScript async await MDN. Globe with Meridians 5. Online coding practice platforms. These help you sharpen your logic. LeetCode, HackerRank, Codeforces, Code Wars, Exechism.io. Practice with a goal. 3 problems a week for depth. Mix easy, medium, and 1 hard per week. Track mistakes and lessons. Link 6. Version control with Git. Start using Git even for practice. Saves your history. Allows experimentation. Encourages frequent small commits. Example: bash git init git add. Git commit m initial problem setup. Use GitHub to host solutions. Share with mentors. Build a public learning journal. Chart increasing 7. Flowcharts and visual aids. Use drawing tools like Draw.io or Excalidraw. Whimsical. Lucid chart. To diagram. Control flow. Data movement. Recursion stack. Algorithm structure. Example: visualize how quicksort partitions a list at each step. Clipboard aid. Cheat sheets and snippet managers. Save time by creating your own cheat sheet in Notion or Markdown. Using apps like Snippets Lab, Boost Note, or Gist. Save common syntax. JavaScript // JavaScript async / await. Example: async function get data, const res equals await fetch, API /data, const JSON equals await res.json, return JSON. Lightbulb 9. Mind mapping and problem breakdown. Use tools like MindMeister, Xmind, Miro. Break a big problem into smaller steps. Input constraints. Data structure needed. Edge cases. Expected outputs. Man in Lotus position 10. Focus tools for deep work. Problem solving requires focus. Tools that help. Pomofocus.io, Pomodoro timer. Forest app, stay off your phone. Notion, to manage notes and daily problem logs. End arrow. Final thought. Tools don't replace thinking, but they amplify your logic, organize your effort, and accelerate your growth. Learn them slowly. Integrate the ones that suit your workflow best. You're not just solving problems, you're building a process. The right tool can make your journey smoother and your victories more frequent. 28. How I developed my own logical skills. When I first started programming, I often felt lost. I would look at a problem and immediately panic. Where do I even begin? How do I know which steps to take first? Logic wasn't something I was born with. I developed it through consistent practice, reflection, and a few very intentional strategies that anyone can apply. In this chapter, I want to walk you through exactly how I built my logical thinking step by step so you can do the same. 1. I broke big problems into tiny pieces. One of the first habits I picked up was breaking a problem down. Instead of trying to solve the entire problem at once, I would ask myself, what is the input? What is the output? What are the small steps I can take to transform input to output? Example: instead of building a full login system, I first focused on taking user input, validating that input, matching credentials in a database, displaying appropriate feedback. This made everything feel achievable and less scary. 2. I made mistakes and analyzed them. Every error I made was a gold mine of learning. I didn't just fix bugs, I understood why they happened. I kept a small log of mistakes I made and what they taught me. Example: once I wrote a loop that never ended. I realized later that I didn't update the loop variable. That one bug taught me more about loops than reading 10 tutorials. 3. I practiced every day, not too much, just enough. Consistency beats intensity. I gave myself just 30 minutes a day to solve a small logic problem or puzzle. I used platforms like LeetCode, Easy/Medium, HackerRank, CodeForces, for brain teasers. Over time, my brain started recognizing patterns. Just like muscles get stronger with daily workouts, my logic got sharper. 4. I taught others, even if it was just to myself. Explaining code out loud helped me identify flaws in my thinking. Sometimes I'd record short videos for myself or write blog posts. This made my understanding deeper. 5. I learned from better developers. I started reading code written by others. I studied GitHub repositories, watched YouTube tutorials, and followed open source projects. Seeing how professionals solved problems gave me new ideas. 6. I built many projects around logic. Instead of building flashy UIs, I made many command line tools. A basic calculator, to practice conditional logic. A quiz game, to use loops and arrays. A to-do list, to work with data structures. These helped me connect theory with real-world use. 7. I focused on why, not just how. When solving a problem, I always asked, why does this work? Why does this fail? This why mindset made me slower at first, but much more powerful over time. I wasn't just copying answers, I was understanding solutions. Final thoughts? Becoming logical isn't about being born smart. It's about building strong habits, being curious about mistakes, practicing regularly, and staying consistent even when progress feels slow. You have the ability to develop amazing problem-solving skills just like I did. Start small. Be patient. And don't stop learning. 29. Advice for young programmers. Starting your journey as a programmer is exciting, but it can also be overwhelming. Between new languages, endless bugs, imposter syndrome, and constantly changing technologies, it's easy to feel lost. This chapter is a letter to every young or beginner programmer out there, filled with the advice I wish someone had given me when I was just starting out. Brain 1. Don't just learn to code, learn to think. Programming is less about memorizing syntax and more about thinking logically and systematically. Ask yourself, what is this problem really asking? Break it down. Understand the flow. Simplify. Every great programmer is just a great thinker with a keyboard. Repeat button 2. Focus on the fundamentals. Mastering the basics of variables and data types, loops and conditions, functions, arrays and objects, algorithms and data structures, is far more valuable than learning the trendiest framework. Frameworks come and go. Fundamentals are forever. Puzzle piece 3. Learn by building. Don't wait until you're ready to build something. You'll never feel ready. Just start. Create a calculator, a to-do app, a blog website, a memory game. The more you build, the more you learn. Theory sticks when you apply it. Lady Beetle 4. Bugs are not enemies, they are your best teachers. You will encounter bugs every day. Embrace them. Debugging is how your brain learns. Every error message is a free mentor in disguise. Instead of feeling frustrated, treat bugs as puzzles. Mantelpiece clock 5. Be patient with yourself. Programming takes time. You will not become an expert in 3 weeks. And that's okay. Everyone learns at a different pace. Don't compare your chapter 1 to someone else's chapter 20. Celebrate small wins. Be kind to yourself. The journey is long, but worth it. Handshake 6. Ask for help, but ask smartly. Google is your best friend. Stack Overflow is your community. But don't just ask for answers, ask to understand. When you ask for help, describe the problem clearly. Show what you tried. Share error messages. You'll get better help and become a better learner. Globe with Meridian 7. Join a community. Programming can feel lonely. Join Discord servers, GitHub projects, Reddit subs, coding bootcamps, hackathons. Being around other learners motivates you and opens doors to collaboration and friendship. Hammer and Wrench 8. Learn tools, not just code. Familiarize yourself with Git and GitHub, version control, VS Code, editor, terminal/CLI, navigation, debugging tools, browser dev tools, breakpoints. These tools are essential for real-world development. Briefcase 9. Build your portfolio early. Start documenting your journey. Share projects on GitHub, blog posts on dev.to or Hashnode, code snippets on Twitter or LinkedIn. Your future self, and employers, will thank you. Red Heart 10. Stay curious. Stay humble. Stay passionate. You won't know everything, and that's okay. Even senior developers Google things daily. Never stop learning. Be open to feedback. Let your curiosity guide your journey. Final words to you. You're not just a beginner. You're the next generation of developers. The web, the apps, the games, they'll be built by people like you. You're doing better than you think. Keep going. 30. Final thoughts. Programming is thinking, not typing. As we come to the end of this guide, there's one final truth I want to leave with you, one that will fundamentally change how you view coding forever. Programming is not about typing lines of code. It's about solving problems with logic, creativity, and clarity of thought. Thought Balloon 1. Code is a tool, thought is the engine. Think of code like a pencil. You can sketch anything with it, but the sketch itself begins in your mind. A beautiful UI starts with an idea. A powerful algorithm starts with a strategy. A scalable system starts with architectural thinking. Before you open your editor, close your eyes and think. Great programmers don't rush to code. They plan, analyze, and visualize. Brain 2. Programming is organized thought. When you write code, you're essentially organizing your thoughts into structured steps that a computer can understand. That's why clear thinking equals clean code. Messy thinking equals bugs, confusion, chaos. Practice mental clarity before code clarity. Counterclockwise arrows. Button 3. Real programming is problem solving. At its core, every program answers a question or solves a problem. For example, a login system answers, how do I verify users? A search algorithm answers, how can I find something quickly? A game answers, how do I create an engaging experience? So ask better questions and seek logical answers. That's what true programming is. Wrench 4. Don't worship syntax, master systems. Beginners often get obsessed with syntax. But experts focus on patterns, example MVC, dry, kiss. Systems, example modularity, reuse, scalability. Principles, example solid, Yagna. Syntax is the alphabet. Logic is the language. Systems are the literature. Balance scale 5. Focus on understanding, not memorization. You don't need to memorize everything. Instead, understand how things work. Ask yourself, why is this code written this way? What would happen if I changed this? Can I explain this to someone else? If you can explain it clearly, you truly understand it. Chart increasing 6. Progress takes patience. Programming will frustrate you. Sometimes the computer won't behave. Sometimes you won't understand the bug. That's normal. What matters is, do you keep trying? Do you reflect on your approach? Do you learn from each attempt? Progress is built on patience. Globe showing Europe Africa 7. Programming is not just for coders. Logical thinking, problem solving, and clear communication, these are skills that improve your entire life. Whether you're a developer, entrepreneur, teacher, or artist, learning to think like a programmer is powerful. Lightbulb. The final truth. Programming is 90% thinking, 10% typing. If you can think clearly, code becomes just another medium, like a brush for a painter or words for a poet. So don't just learn to code. Learn to think. That's the secret to mastering programming and life.